Hey there guys, welcome to my walkthrough of the Edexcel Higher GCSE Maths Paper 3 from June 2017. So it's the second calculator paper, hopefully it won't be as bad as paper 2. There will be lots of useful stuff linked below in the description, so make sure you take a peek, including my playlist containing every Edexcel Higher GCSE 9 to 1 Maths past paper walkthrough. Okay, let's go. Okay, question 1, a Venn diagram. So the universal set is all of the odd numbers less than 30. Set A contains 3, 9, 15, 21, 27, and set B contains 5, 15, 25. But I want us to complete the Venn diagram to represent this info. Okay, so any number that's in neither set goes in the rectangle, so 1. Then the next odd number is 3, which is in A but not B. So we need to label our circles 2. So 3 is in A, 5 is in B but not A, 7 is in neither, 9 is in A but not B, 11 is in neither, 13 is in neither, 15 is in both, so that goes in the middle, 17 neither, 19 neither, 21 is in set A, 23 is in neither, 25 is in B, 27 is in A, and then 29 is in neither. Okay, then part B says a number is chosen at random from the universal set. So one of the odd numbers less than 30 is chosen at random. What is the probability that the number is in the set A union B? So that means A or B. So we know the total number of numbers in the set is 15, so that's the bottom of the fraction. Now, A union B means all of the numbers inside of the circles. So we got 1, 2, 3, 4, 5, 6, 7. So it's 7 over 15. Cool. Okay, number 2 wants us to solve the simultaneous equations 3x add y is equal to minus 4 and 3x minus 4y is equal to 6. If you struggle with these, my playlist is down below. So, both equations have a 3x in them. Now that means we can eliminate the x terms from both by using subtraction. So the very first thing we're going to do is call the equations 1 and 2. So, to get rid of the x terms, we can either do equation 1 minus equation 2 or 2 minus 1, either way. So, I'm going to do 2 minus 1. So, 3x minus 3x by x minus 4y minus 1y gives us minus 5y. And then we're doing 6 minus 4. So that's 6 add 4, which is 10. Now if we divide by minus 5, we get y is equal to minus 2. So now that we know y, we can track down x. So substituting y is minus 2 into, I'm going to put it into equation 1. We are going to get 3x minus 2 is equal to minus 4. Add 2 to both sides. 3x is minus 2. Divide by 3x is minus 2 over 3. So, we've done it. Cool. Okay, number 3. The table shows some information about the dress sizes of 25 women. Part A wants us to find the median dress size. Okay, so we know then like 2 women are size 8, 9 women are size 10, etc. We could write out all of this info, but we would need to write out 25 things, and then the median would be the middle one in those 25 things. We don't want to do that. So what we can do instead is find the number of the piece of data which would be the median. So if we put all 25 of these women in order, we could find which number woman would be the middle one and then get our dress size. So the way to do this, if you have an odd number of things as we do here, you add 1 to it and divide by 2. So 25 add 1 is 26. 26 divided by 2 is 13. So the 13th woman is the median. Now we go through the frequencies and add them up until we get 13 or above. So in the top there's only 2, so the 13th is not in there. Then we add 9, that's 11, still haven't got the 13th. Then we add the 8, that's 19, so the median woman is in there, which means the median dress size is 12. Okay, then for part B, where we have a bit of probability. So 3 of the 25 women have a shoe size of 7. Zoe says that if you choose at random one of the 25 women, then the probability she has either a shoe size of 7 or a dress size of 14 is 9/25, because 3/25 add 6/25 is 9/25. Is Zoe correct? you must give a reason for your answer. Okay. So, the 6 out of 25 comes from the fact that 6 women have a dress size of 14. However, there's nothing here to say that a woman can't have a dress size of 14 and shoe size of 7. So, Zoe is not right, because a woman might have both. Okay, number 4, a nice 5 marker all about kicks. Good times. So, Daniel makes 420 kicks. He makes vanilla cakes, banana cakes, lemon cakes, and chocolate cakes. 2/7 of the cakes are vanilla, 35% of the cakes are chocolate. The ratio of lemon and chocolate cakes is 4 to 5. Our job is to work out the number of lemon cakes Daniel makes. So, quite nice for 5 marks, to be fair. So, first of all, let's work out how many vanilla cakes he makes, how many banana cakes he makes. That's then going to allow us to work out how many lemon cakes and chocolate cakes he makes, which we can then faff around with the ratio. Okay, so for the vanilla, that's 2/7 of 420. Now if you want to, you can do that on your calculator. Just put in 2/7 times 420 and you will get 120. Okay, then for the banana cakes, 35% of 420 Now for that, you can do 0.35 times 420, and that gives us 147. Now, if we now add these together, so vanilla and banana is 267. So that means lemon and chocolate together have to make up 420 minus 267. So that's 153. Okay, so now we know then there are 153 altogether lemon cakes and chocolate cakes. Now we know that lemon to chocolate is in the ratio 4 to 5. So we need to split 153 in the ratio 4 to 5. So 4 and 5 is 9, so one lot of the ratio is 9 cakes. We then want to know how many lots of 9 cakes are in 153. So we do 153 divided by 9, and that gives us 17. So finally, the number of lemon cakes is 4 times 17, because there are 17 lots of this ratio. So 4 times 17 is 68. Boom. Number 5, angles in polygons. So in the diagram, AB, BC and CD are 3 sides of a regular polygon P. We want to show that polygon P is a hexagon. You must show your working. Okay, so the 3 sides are these guys. Now, what do we know? Well, if we zoom in on one of these points, we know that in a square, all the angles are 90 degrees. So, that angle is 90 degrees. All we need to do is find these other 2 angles around this point. So, let's first of all find what the interior angle of a hexagon should be. You might know it, you might not. This is how we work it out. So, there's a hexagon. Now, what we do is from one of the corners, we draw straight lines to any other corner that we can. So I'm going to go there, there, and there. So what I've now done is created 4 triangles. Each triangle contains 180 degrees. So the sum of interior angles is 4 times 180, which is 720. Now, if it's a regular hexagon, all the angles are the same, so that means 1 interior angle is 720 divided by 6, which is 120 degrees. So, we need to show that this angle here is 120 degrees. So, how in the world are we going to do that? Well, we need to play around with the 12-sided polygon. Now, the way that that's going to be useful is that we're going to also think about its exterior angles. So, the exterior angles of a shape are, if this is part of a polygon, an exterior angle is when you carry on one of the sides and it's then the angle between that and the next side of the shape. So there are two important things here: the sum of exterior angles for any number side shape is always 360 degrees. So, however many sides a shape has, as long as it's regular, you can find its exterior angle by dividing 360 by the number of sides. Now, also, exterior and interior angles make up angles on a straight line. So, interior and exterior always adds up to 180 degrees. Now, using these two facts, we can first of all work out the exterior angle of the 12-sided polygon. So, so that's 360 divided by 12, which is 30 degrees. So we then know that the interior at 30 is 180. So the interior angle is 150. So if we go back up here, we now know that this angle is 150 degrees. Now, the right angle is 90 degrees. So if we do 90 at 150, we get 240. So the interior angle of polygon P, remember angles around a point add up to 360, so it's 360 minus 240, which is indeed 120 degrees, so P is a regular hexagon. Go. Okay, number 6. It looks a lot scarier than it is. So the density of apple juice is 1.05 grams per centimetre cubed. The density of fruit syrup is 1.4 grams per centimetre cubed. The density of carbonated water is 0.99 grams per centimetre cubed. 25 centimetres cubed of apple juice are mixed with 15 centimetres cubed of fruit syrup and 280 centimetres cubed of carbonated water to make a drink with a volume of 320 centimeters cubed. Work out the density of the drink. Give your answer correct to 2 decimal places. Okay, so density, if you're still not sure, you're actually given the formula for density, it's just hidden. So when we have grams per centimetre cubed, that means grams over centimetres cubed. Grams is a mass, centimetres cubed is a volume. So density is mass divided by volume. So what we need to do is work out the mass of the drink because we know the volume. So mass is density times volume. So for the apple juice, we want to do 1.05 times 25. Now that gives us 26.25. Now that's a mass, so that's grams. The fruit syrup, for that we're gonna do 15 times 1.4. That gives us 21 grams. And then for the water, we're gonna do 0.99 times 280. And that gives us 277.2. Okay. From this, we can now work out the total mass. So add those three together and you should get 324.45. So the density is 324.45 grams divided by the volume of the drink, which we know is 320 centimeters cubed. Now to 2 decimal places, that gives us 1.01. Cool. Okay, number 7, nice straightforward bit of SOHCAHTOA. So ABC is a right angled triangle, so we know one angle is 23 degrees and the hypotenuse is 15 centimeters. Our mission is to calculate length AB, giving our answer correct to 3 sig figs. Okay, so AB is this length over here. Now that to the angle is the opposite. the 15 centimeters is the hypotenuse. So we then go to SOHCAHTOA. My playlist on this is down below, by the way. So, do we want SOH? Yes, we do. So, SO tells us sine of the angle is equal to the opposite over the hypotenuse. So we know that sine 23 is equal to the opposite divided by 15. Now to move to 15 we multiply through by it, so we get the opposite is 15 sine 23. So plug that in your calculator and we should get at 3 sig figs 5.86 centimeters. Cool. Okay, number 8. A square with sides of length x centimeters is inside a circle. Each vertex of the square lies on the circumference of the circle. So, vertex means corner. Here's a sketch. So, I would highly advise making a sketch yourself too. We are told the area of the circle is 49 centimeters squared. Work out the value of x. Give your answer correct to 3 sig figs. Okay, so x then is the side length of Mr. Square. Now then, the only thing really that we know is the area of the circle is 49. I'll be really careful there as well because I've made a square number. 49 centimeters squared. So from that, we can work out the radius of the circle. Now that's going to help us because the diameter of the circle is the diagonal of this square. So let's start then with the area of the circle. So if you don't know this, it is in my formula video, which is linked down below, from which you can get a printable PDF copy. Good times. So the formula for the area of a circle is pi r squared. So we know pi r squared is equal to 49. So r squared is 49 over pi. So r is the square root of 49 over pi, and that gives us 3.95 centimeters. Now from that, we can get the diameter is 2 times that, so 2 times 3.95 is 7.9. So the diameter of the circle, which is the diagonal of the square, is 7.9 centimeters. Okay, so back to the square. So we can now say that our length is 7.9 centimeters. Okay, how does that help? Well, by splitting the square like that, we've made two right-angled triangles. So, let's make a sketch. So we now have a right-angled triangle with both shorter sides being x and the longer side being 7.9. So, what can we play with in right-angled triangles? Pythagoras. So, by Pythagoras, x squared add x squared is equal to 7.9 squared. So 2x squared is equal to 62.41. So we now want to solve this for x, so divide by 2. So x squared is 31.205. Square root that, and we get x is 5.586, blah blah blah, which to 3 sig figs is 5.59. Boom. Okay, number 9. The box plot shows information about the distribution of the amounts of money spent by male students on their holidays. Part A wants us to work out the interquartile range for the amount of money spent by male students. Okay, so the interquartile range is the difference between the upper quartile and the lower quartile. So on a box plot, the right hand side of the box is the upper quartile and the left hand side is the lower quartile. So if we go down, check out the scale. So 5 little squares represents 100. Every little square then is 20. So the lower quartile is in the middle. So that's going to be 150. And the upper quartile is just to the right of 300. So 1.5 in from 300, so that's 330. So the interquartile range is 330 minus 150, which is 180 pounds. Cool. Okay, then for part B, we're given some info for female students and asked to draw their box plot on the grid above. So, the smallest amount is the left hand whisker, largest amount is the right hand whisker, lower quartile is the left of the box, upper quartile, right of the box, median is the line in the middle of the box. So, you should get something looking like that. Okay, then for part C, Chris says that the box plots show that the females spend more money than the males. Is Chris correct? Give a reason for your answer. Okay. So, if we look at the two box plots, so even though the blokes have a higher largest amount, that might just be one person, an outlier. So, if we look at the females, then they have a higher median. Now the median is the middle value. So I would say yes, Chris is correct because the females have a higher median. Cool. Okay, number 10. Compound interest with unknown percentage interest. So, Naomi invests £6,000 for 5 years. The investment gets compound interest of X% per annum, so per year. At the end of 5 years, the investment is now worth £8,029.35p. We want to work out the value of X. Okay. So, I'm going to do this thinking of decimal multipliers. Say that the investment was paid 2% interest per year. We would do 6,000 times 1.02 to the power of 5. Problem is, we don't know the percentage, it's X%. So, I'm going to call the decimal multiplier Y. So, I'm going to say that £6,000 times the decimal multiplier Y to the power of 5 is equal to £8,029.35p. Okay, so we're trying to find Y. When we know the multiplier, we can then get the percentage interest. So we have 6,000 times Y to the power 5. To move to 6,000, we divide by it. So we get Y to the power 5 is 8,029.35 divided by 6,000. Now that gives us 1.338225. So Y then is the 5th root of that. Which gives us 1.06. Now, if you multiply a number by 1, it's not very exciting, you're just finding 100% of that number. The part that increases it is the decimal after. So the increase is the 0.06. Now 0.06 as a percentage times by 100 is 6%. So X is 6%. Cool. Okay, number 11, we have combinations. So Jeff is choosing a shrub and a rose tree for his garden. How nice. At the garden centre there are 17 different types of shrubs and some rose trees. Jeff says there are 215 different ways to choose one shrub and one rose tree. Could Jeff be correct? You must show how you get your answer. Okay, so the total combinations is the number of shrubs times the number of rose trees. So, if he's right, 17 times something times a whole number will give us 215. On the flip side then, if we did 215 divided by the number of shrubs, we should get a whole number for the rose trees. So 215 divided by 17 sadly gives us 12.6, which makes no sense. There can't be 12.6 different types of rose tree. So, no, Jeff is wrong. Number 12, some ratio of funds, so the points A, B, C and D lie in order on a straight line. AB to BD is 1 to 5 and AC to CD is 7 to 11. We want to work out the ratio AB to BC to CD. Okay, so first up, let's draw a straight line. Now we know that A is at one end and D is at the other. Okay, now if we look at the two ratios, AB to BD is 1 to 5, so that's breaking the line into 6 parts. But AC to CD is 7 to 11, that's breaking the line into 18 parts. So, we need to turn AB to BD into a ratio with 18 parts as well. So to do that, we can multiply 1 to 5 by 3. So AB to BD is 3 to 15. So, now we know that. We now know then that AB is 3 long. We know that CD is 11 long. So, from that, we can work out that BD, well, the line has to be in 18 parts. At the moment we have 14 parts, so BC must be 4. So A, B, BC to CD is 3 to 4 to 11. Good. Okay, number 13, we have inequalities on graphs. So we want to write down the 3 inequalities that define the shaded region. Okay, so the shaded region is bounded by 3 lines. Essentially, we need to find the equations of the 3 lines and then decide whether the region is above or below each line. So the easiest one to do is this horizontal one. So this horizontal line is y is equal to minus 2. Now the shaded region is above that line, so the first inequality is that y is greater than or equal to minus 2. All of the inequalities are or equal to ones because all the lines are whole and not dashed. So the first one is y is greater than or equal to minus 2. Okay, on the next line, let's do this one that goes through 0, 0. So it goes through 0, 0. It also goes through 1, 1. It also goes through 2, 2. So this line is y equals x. Now the region is above that line, so that inequality is y is greater than or equal to x. Okay, then the third one not so easy. So it goes through 0, 1. It goes through then 2, 2. Okay, so we need to find the equation of this line. So 0, 1 and 2, 2. Okay, so the general equation of a line is y is mx add c. C is the y-intercept, so we actually know that is 1, and m is the gradient. So we can actually say then that y is mx add 1. Now again, that's because we go through the y-axis at 1. Now the gradient is difference in y over difference in x. So we're going to do it as 2 minus 1 over 2 minus 0, which gives us 1 over 2, which is a half. So the equation of this line is y is half x add 1. Now, the region is below that line, so the inequality for that one is y is less than or equal to half x add 1. Boom. 14a algebraic fraction wants us to simplify x squared minus 16 over 2x squared minus 5x minus 12. Okay, so the trick to simplifying algebraic fractions is always to factorise. You can't do anything before you've factorised. So, often one of either the top or bottom is easier to factorise than the other. So here it's the top. X squared minus 16 is a difference of two squares, and it factorises to x plus 4 times x minus 4. Okay, so that's the top. Now the bottom, to be able to simplify this fraction, there must be a common factor on the bottom as there is on top. So that tells us one of our brackets on the bottom is going to have a single x and a 4. So 2x squared minus 5x minus 12. Now to get a 2x squared, one bracket has to have 2x. Okay, so one of our brackets on, as I said, has an x and a 4. Now to get the minus 12, or to get the 12, we're going to need a 3 in the bracket with the 2x. Okay, so now we need to get a minus 5x in the middle. So if we did minus 4 times 2x, that would get us minus 8x, and then a plus 3 in the other bracket would then get us plus 3x. So that would take us up to minus 5x. So it's that way around. So we got 2x plus 3 times x minus 4. So if we think of this back as a fraction now, we have x plus 4 times x minus 4 over 2x add 3 times x minus 4. There's a common factor of x minus 4, so that cancels out. And we get left with x add 4 over 2x add 3. If you want more examples, check out my algebraic fractions playlist down below. Okay, number 15. So we have a triangle ABC whose area is 6 root 2. One angle of 45 degrees and the two side lengths. Coming out of the angle, x add 3 and 2x minus 1. Our job is to calculate the value of x at 3 sig figs. So, area of a triangle is usually where you can base times height divided by 2. Here we don't know the height. Bugger. So there is another way to work out areas of triangles, and the reason that we want to do this is so that we get an equation in terms of x. If we can work out the area in terms of x, set that then equal to the area 6 root 2. So, again, this is in my formula sheet, the video of which you can get down below, where you can also get a printable PDF copy. So, if you have a triangle and you know an angle, we'll call it theta, and you know the two sides coming out of it, usually A and B, area is 1/2 AV sine theta. So, using that, we can say that 1/2 times x add 3 times 2x minus 1 times sine of 45. Whack that in your calculator, you get root 2 over 2. Well, we know that that is equal to 6 root 2. Now, as soon as we got that, we don't care about the triangle anymore. We now want to solve this equation for x. Okay. So, on the left, we have 1/2 times x add 3 times 2x minus 1 times root 2 over 2. Now, 1/2 times root 2 over 2 is root 2 over 4. So, we have root 2 over 4 times x add 3 2x minus 1 is equal to 6 root 2. Now we can divide both sides by root 2, so the root 2 goes by, and if we multiply both sides by 4, we get rid of that over 4 on the left. So we get x add 3 times 2x minus 1 is equal to 6 times 4, 24. Now if we expand the brackets, we get 2x squared. Then we get 3 times 2x, so that's 6x, minus 1 times x, so that's add 5x, minus 3, and that is equal to 24. Now then, this is a quadratic. To solve quadratics, you always want a 0 on the right and every other term on the left. So we're going to get rid of that 24 by subtracting it. So we're going to get 2x squared, add 5x, minus 27 is equal to 0. Okay, so that now is our quadratic that we need to solve. Now then, the fact that they've told us they want the answer to 3 sig figs tells us we can't factorise this, so we need to use the formula. Now again, formula is in my formula video and formula sheet. It tells us that x is minus p plus or minus root p squared minus 4ac all over 2a. So, for us, a is 2, b is 5, c is minus 27. So, x is minus 5 plus or minus the square root of 5 squared, so that's 25, minus 4 times 2 times 27. So 4 times 2 is 8, 8 times 27 is 216. So we got minus 4 times 2 times minus 27. So that's going to give us add 216. Now just to save space, 25 add 216 is 241. And then that's all over 2 times 2, which on a good day is 4. Now, x cannot be negative because one of the sides is 2x minus 1. You can't have a negative length. So, x can't be negative. So, x is minus 5 plus root 241 all over 4 and 236, that gives us 2.63. Cool. Okay, number 16, iteration. Literally the easiest marks to pick up, as long as you know how to use your calculator. So, for the full experience, check out my video down below. So, using xn add 1 is minus 2 minus 4 over xn squared, with x naught as minus 2.5. Part A, find the values of x1, x2 and x3. Okay, so to do this, put minus 2.5 into your calculator and press equals. You'll get minus 2.5. Now, what you now want to do is put in the right hand side of the iteration formula using the ANS button for the xn. So, in your calculator, after you've put in minus 2.5 and pressed equals, then put in minus 2 minus 4 over aunts squared. So, and then press equals, and that will give you x1. which should be minus 2.64. Press equals again, that gives you x2. And so they're all gone to 3 decimals, minus 2.574. Press equals again, and then there is x3. So for that, I get minus 2.604. Okay, then part B wants us to explain the relationship between x1, x2 and x3 and the equation x cubed add 2x squared add 4 is equal to 0. So, iteration is a way of solving hard equations that you can't factorize or do some other magic too. So, we can actually rearrange this into the iteration formula. So, if we subtract 2x squared and 4, we get x cubed is equal to minus 2x squared minus 4. If we then divide both sides by x squared, we get x is equal to minus 2 minus 4 over x squared. Now this is where the iteration formula comes from. So x n add 1 is minus 2 minus 4 over x n squared. So the relationship is that x1, x2 and x3 are estimates of the values of x that satisfy x cubed add 2x squared add 4 is equal to 0. So we are finding the values of x that solve that equation. Cool. Okay, number 17, we have bounds. So a train travelled along a track in 110 minutes, correct to the nearest 5 minutes. So, straight away, let's write down the error interval for the time. So, the time could have been between 107.5 and 112.5. Remember, the upper bound is always a strict inequality. We're told Jake finds out that the track is 270 kilometers long. He assumes that the length of the track has been measured correct to the nearest 10 kilometers. Okay, so the error interval for the track is, so I'm calling that distance. So it can be from 265 kilometers to 275 kilometers. Okay. We were asked, could the average speed of the train have been greater than 160 kilometers per hour. You must show how you get your answer. Okay, so speed is distance over time. Now, what we want is the upper bound for the speed, because we're asked, can it be greater than 160? So the upper bound, which we'll call S U, well, it's the longest distance. So the upper in the shortest time, so T lower. Now then, we know that the upper bound for the distance is 275 kilometers. Now, we want kilometers per hour, so we need to turn the lower bound for the speed, sorry, for the time, into hours. So to do that, we divide by 60. So, the lower bound of the time is 107.5 divided by 60. And that gives us 1.79 kilometers per, 1.79 hours. So, if you work that out, you should get 153 point whatever, so 153 would be fine. So that's kilometers per hour. So that, with the info that we got, is the fastest that the train could be going. So, could it be going greater than 160? No. Okay, then for part B we're told Jake's assumption was wrong. The track was measured correct to the nearest 5 kilometers. He assumed to the nearest 10 kilometers. Part B wants us to explain how this could affect your decision in part A. Well, with a smaller rounding amount, so to the nearest 5 instead of the nearest 10, the maximum possible distance of the track is going to be even smaller. So the top of our fraction, distance upper, would be smaller than it was up above. Now, it already wasn't long enough to give us a fast enough speed, so if it gets even shorter, it's still not going to be long enough to give us a fast enough speed, so it's actually not going to affect our decision at all. Okay, another fun one, number 18. So here we got Selk theorems, Selk and sectors yet a good time. Okay, so A, B, and C are points on a circle of radius 5 centimeters, center O. The A and the C are tangents to the circle. So, there's a circle theorem here that says when tangents come out of a point, the same point, and hit the circle, they are the same length. So this line and that line are the same. The O is 9 centimeters. Okay, so that's this line here. And we are asked to work out the length of the arc ABC to 3 significant figures. So the arc that we want is that guy, all the way around like that. Okay, so how are we going to do that? Well, first of all, let's work out the circumference of the whole circle. So, circumference is pi times diameter. Diameter is 2 times the radius. So the circumference is 10 pi centimeters. Okay, so what we need to know is what fraction of the circumference this arc is. So for that we need to know what fraction of the circle it belongs to. Now to do that, we use the fact that angles around a point add up to 360. And what we're going to need to do is find that angle around like that. So let's call that theta. So to find the fraction of the circle that we have, we need to find theta and stick that over 360. For example, if theta was 90 degrees, we would have a quarter of the circle. So the arc length is whatever we find theta to be over 360 times the circumference, so times 10 pi. Okay, so how in the world do we go about then finding theta? Well, these two triangles are congruent. Now we know that because both of them have a right angle and both of them have all 3 sides the same. So that means that this angle and this angle are the same. So if we can find one of these angles, we can find the entire blue angle, take that away from 360, boom, there's theta. So let's pull out a sketch of one of these triangles. So we know the radius is 5. Now we know the radius is connected to the right angle. So that's going to be our 5. Now we know the hypotenuse is DO, and that is 9. Now the angle that we want is this chap. So let's call it X. Now with respect to angle X, this is the adjacent, this is the hypotenuse. So is it so? No. Ca? Yes. So we know that cos X is 5 over 9. So x is the inverse cos. So x is the inverse cos of 5/9, which gives us 56.3 degrees. Now, if we go back to the circle, those two angles are the same. So, we can now work out this entire blue angle by doing 2 times 56.3. And that gives us 112.6. From that, we can now work out theta. So, theta is 360 minus that. And that gives us 247.4. So we can now finally work out the arc length. So the arc length then is 247.4 over 360 times 10 pi centimeters. Now they wanted the answer to 3 sig figs, so you should get 21.6. Cool. Okay, number 19, we are solving a quadratic inequality. Check out the playlist down below. So we want to solve 2x squared add 3x minus 2 is greater than 0. So that's asking for what values of x can we plonk into this quadratic so that the value is greater than 0. Now the way that we do this is by thinking of the graph. So we're going to sketch the graph, and then we want the values of x that create the part of the graph above the x-axis. So what we do first of all is think about the equation of this, not the inequality. So we find the points where the graph crosses the x-axis. So we set 2x squared add 3x minus 2 equal to 0. Now the nicest way to solve this would be to factorise. So given we got a 2x squared, one of the brackets needs a 2x. Now our two numbers need to multiply to minus 2. There aren't many numbers that multiply together to give us 2, it's just 1 and 2. So, given that we have a minus 2, one number is going to be positive, one is going to be negative. So, if we were to put a plus 2 in there, we're going to get 2 times 2x, which is 4x. If we then put minus 1 there, we get minus 1 times x, which is minus x. So 4x minus x gives us the 3x in the middle. Now, you set whatever is inside each bracket equal to 0 and solve for x. So, if we have 2x minus 1 is equal to 0, 2x is 1, so x is a half. Or if we have x add 2 is equal to 0, x is minus 2. So we can now sketch the quadratic. It's got a positive x squared, so it's a happy quadratic. There, happy quadratic. So we cross the x-axis at minus 2 and 1/2. So something like that. Now what we want are the x values that create that part and that part of the graph. So x is, now there's strict inequalities because this was a strict inequality. So we want x is less than minus 2 or x is greater than positive 1/2. Boom. Okay, number 20, we've made it to the end. If you're still here, hold on. So, part A, the equation of a curve is y is a to the power of x. So it's an exponential curve. A is the point where the curve intersects the y-axis. We want to state the coordinates of A. Okay, so you wouldn't need to do this, but I'm going to do a sketch. So, exponentials always look like that. Now, point A is on the y-axis. Now, on the y-axis, x is equal to 0. And y then would be a to the power of 0. Any number to the power of 0 is 1. So the coordinates of A are 0, 1. Okay then, for part B, the equation of circle C is x squared and y squared is equal to 16. So that's a circle centered at 0, 0 with a radius of 4. In fact, let's sketch it. So there's circle C, so this would be 4, 0, this would be 0, 4, this would be minus 4, 0, and this would be 0, minus 4. So this is circle C. Okay, we're then told circle C is translated by the vector 3, 0 to give circle B. So the vector 3, 0 moves us 3 places to the right, and that's it. We want to draw a sketch of circle B, label with coordinates the centre of circle B, and any points of intersection with the x-axis. So we don't need to worry about the y-axis. Okay, so all that's going to happen is circle C goes right by 3. So circle B then, well, we know the centre is going to be 3, 0. Because it was 0, 0. We know the left-hand intercept on the x-axis is now going to be minus 1, because it's 3 to the right of minus 4. And the right-hand one is going to be 7. So, it's going to look something like that. Now, just as a final bonus question, I wonder if anyone can tell me down below how we would work out the coordinates of the y-intercepts. Have a little think, let me know down below. Okay guys, that's the paper done. Hope you found it useful. Again, quite a tricky one, particularly here at the end. Don't forget you can get to every past paper walkthrough down below in the description in one playlist. If you haven't yet, there's lots of useful stuff down there, so make sure you take a peek. Give us a thumbs up, get subscribed, take it easy, take care, have a great day.